Okay, today we're going to be looking at combinations. So, combination. So previously we've looked at permutations. And a permutation is when the order matters. So permutation is the way in which selected objects are arranged in a particular order. Whereas a combination is just a way of selecting objects. And that doesn't matter. The order doesn't matter. So for example, if you went to an ice cream parlour and you were choosing strawberries and ice cream, choosing strawberries and ice cream is the same as choosing ice cream and strawberries. It doesn't matter which way you choose them. So the number of possible combinations, so if you're choosing R objects from N objects in no particular order, this is the combination, and the number of combinations is found by this notation. So you do C, N, number of objects, R, how many objects you're choosing, and it is N factorial over R factorial N minus R factorial. Now you've already met this if you have done any work with binomials, and this is the old way, this old notation for writing this. The more modern notation is writing N over R in this way. It means the same thing. Now let's just have a look again at how this relates to permutations. So we had previously the for P, the number of permutations for N objects, and we're choosing them in n different ways, is just N factorial. And we also found out that if we have repeats in our set that we're looking at, we have NPR, which is N factorial N minus R factorial. So this is the permutations for R objects from N distinct objects. Now, with this, we can have a wee look at how these are related. So if we have N objects and we're choosing R of them, let's think about this in a real life situation. So imagine you're picking 3 children from a group of 5. So here is our 5 children. Here's 5 children, and we want to pick 3. Now we can view this as choosing 3 and ignoring 2, or as choosing to ignore 2 and remaining with 3. It doesn't matter how we view this, that it's the same problem. So if you look at 5 and choosing 3, or 5 and choosing 2, they're going to be the same, because you'd have 5 factorial, here you would have 3 factorial, and then 5 minus 3 is 2, or you would have 5 factorial. Let's write it down so we can see it. 5 factorial over 3 factorial, 5 minus 2 factorial, and that's the same as 5 factorial, 2 factorial, 5 minus, sorry, it's meant to be 3, 2 factorial, that's going to become 2, that's going to become 3, and you end up with the same thing. Another thing to note is when you've got a combination, there's fewer combinations than there are permutations. So let's do a few examples and see how this works in practice. So in how many ways can 3 fish be selected from a bowl containing 7 fish and 2 potatoes? So, how many objects do we have? Do we have 7 or do we have 9? Well, we're just dealing with fish, so we only need the 7 fish. So we've got 7 fish and we want to choose 3. So that's going to be 7 factorial divided by 3 factorial times 7 minus 3 is 4 factorial, which is 35 ways. The potatoes are irrelevant. In how many ways can 5 books and 3 magazines be selected from 8 books and 6 magazines? So what we need to do is split this up into 2 parts. We need to deal with the books and then we need to deal with the magazines. So we've got 5 books, we want 5 books, and we've got 8 to begin with. So we've got 8 books and we want 5, so that's going to be 56 ways. And we also want 3 magazines and we're picking from 6 magazines, so that's 20 ways. Now, because the books and magazines are selected independently, we multiply the number of combinations. That's a terrible 8. There we go. So it's 56 times 20, which is 1,120 ways. Let's look at another one. So we have a team of 5 is to be chosen from 6 6 women and 5 men. Find the number of possible teams in which there will be more women than men. So again, we're going to have to split this up. So let's think of the different combinations. So here we have from the 6 women and from the 5 men. Now, what can we have? We can have 3 women and 2 men. So we're thinking how many ways to make up 5, a team of 5, but the majority must come from women. We can have 4 women and 1 man, and we can have all women and 0 men. So we can work this out. So we would do the number of teams. So we're going to have, wait a minute, that's going to give us enough space. Let's get rid of this line here. So we have 6 women chosen from 3 women chosen from 6 women, and we'll multiply that by the 5 men, and we take 2 of them, and that'll give us 200 possible combinations. Here we have 4 women, again being chosen from 6, and here we only have 1 man from the 5, and that gives us a possible of 75 choices. And finally we have our 6 women again, and we're choosing all 5 from them, and here we have our 5 men, and we're choosing no men, and there'd be 6 possible ways of doing that. So now we add up the different combinations for each possibility. So we have 200 plus 75 plus 6 equals 281 teams with more women than men. Now let's do another one that's a bit more tricky. This one's going to use a combination of permutations and combinations. How many distinct 3-digit numbers can be made from 5 cards with each of the following digits? So we've got 5, 5, 7, 8 and 9. Now the first thing to note is we've got a repeat here of 2 5s. So this means that we're going to have to investigate the different situations separately. So we can have a 3-digit number where there's no 5s, because we can make 3-digit numbers from 7, 8 and 9. We can make a 3-digit number and have 1 5 in it, or we could have a 3-digit number with both 5s in it. So let's consider first the no 5s selected. So this is going to be using the permutations because the order is going to matter. So we've got three different numbers to choose from. So it's just 3p3, which is 3 factorial, which is 6 possible 3-digit numbers. Now what if we have 1, 5 selected? So in this situation, let's think about this. We've got our 3-digit numbers, and one of them is going to be a 5. We don't know where that 5 is going to be. That means that we can only pick 2 from these 3 digits remaining. So this can be a combination. We've got our 3 possible numbers and we're choosing 2 of them. And then we're multiplying this by the 3 factorial because we'll have 3 different numbers and they will be, again, it's a permutation. There's only 1 5, so we have 3 factorial ways of arranging those 3 numbers, and that gives us 18. Now we have 2 5s selected. So this is now the combination where, well, we can only, so now if we have 2 5s, there's only 1 space left, so we need to choose 1 number from these. So we've got our 3 and we're choosing 1 possible number. Now this time it's going to be 3p2 because we have this situation where we've got a repeat. And that gives us choose 1 times 3 factorial over 2 factorial, which is going to give us 9. So these are the different combinations from the nose 5s, the 1 5, the 2 5. So we add these together. So we've got 6 plus 18 plus 9 equals 33 3-digit numbers. The selections in these 3-digit numbers are mutually exclusive, so that's why we add together the numbers of the 3-digit numbers here. So we add these together. So